Okay, I'm now recording, so you can turn off your cameras now. I'll have you turn on your cameras during the exam, but not during lecture. Let's see. I don't know why I'm getting all this extra stuff popping up here. All right, so 14.4 today. I'll lecture a while, quote unquote, get that out of the way. So most likely on Thursday, I'll go to 14.5 and maybe more. I'm not sure on the next exam date yet. I'll see how that goes. A reminder, a week from today, Tuesday is Flex Day, Tuesday the 2nd. So no City College classes on that day. Okay, so 14.4. Okay, so we were doing tangent planes to level surfaces. Okay, and linear approximations, 14.4, page 927. So this is the one that we're using, page 928. Z minus Z0 equals partial of f with respect to x minus x0 plus partial with respect to y times y minus y0. Okay. All right, and then for differentials, page 932, dz is partial with respect to x dx plus partial with respect to y dy. Okay. If you have a function of 3 variables, say w, dw is partial of w with respect to x dx plus partial of w with respect to y dy plus partial of w with respect to z dz. Okay, so 14.4 homework. I'll go ahead and mark it here. So 1 to 5, 11 to 17, 25 to 31. Only do the linearization. So evidently for 25 to 31, it says to do stuff beyond that. Just do something called the linearization if it asks you for that. Okay. All right. So here we go. As usual, I have to show you at least one of each type. Okay. Number 1, z equals 2x squared plus y squared minus 5y at the point 1, 2, negative 4. Please notice the analogy between this and in Calc 1, right? Find the equations of the tangent line to the curve y equals, I don't know, x squared minus sin x at the point where x is equal to 4 or whatever. Okay, so this time we're doing tangent planes. All right, so you need the partial with respect to x, differentiate with respect to x, it's 4x. Differentiate with respect to y, 2y minus 5. Then I plug in at 1, 2, negative 4. That's just like in Calc 1, right? You find a derivative in general, then you plug in whatever x or y values happen to be. So now I plug in x is 1, y is 2, z is negative 4. So if I plug in 1 here, z sub x is 4, partial of z with respect to x. Z sub y is negative 1, 2 times 2 minus 5. Okay, now it's just a straight plug-in. Z minus Z0, Z minus a minus 4 equals, I mean, that looks almost exactly like y minus y1 equals m times x minus x1. And then you just have the same thing except, you know, the derivative with respect to y and then y minus y1 or y0 here. So z plus 4 times x minus x0, x minus 1, minus 1 z sub y times y minus 2. And just clean it up. Z plus 4 equals 4x minus 4 minus y plus 2. So 4x minus y minus z equals 6. Okay, or z equals 4x minus y minus 6, writing it as a function. Okay, so the linear approximation as a plane to this graph at the point 1, 2, negative 4 is this. It's a best planar approximation. Okay, so remember we're approximating with tangent planes as opposed to tangent lines, right? So maybe a picture like that. You see the curve, and then below that in orange, you have a tangent plane, perhaps. Okay. Like I said before, this is a good picture showing that figure 2. Okay, tangent plane, and then you zoom in and you zoom in more as you zoom in more and more, the approximation gets better and better. Okay. Okay, then number 5, z equals sine of x plus y at the point -1, 1, 0. Okay. So there's some graph in 3D, right? What's the equation of the tangent plane? That's just like Calc 1 tangent line. So differentiate with respect to x, product rule. So first function x times the derivative of the second. Derivative of sine x plus y is cosine x plus y times the derivative of the inside with respect to x, but that's 1. Plus second function, sine of x plus y, times the derivative of the first with respect to x, but that's just 1. Okay, so you don't have to put anything extra there. All right, then I plug in z sub x at -1, 1, 0. So put a -1 there, -1 there, 1 there. Okay, and likewise here, a -1 plus 1 is 0. Sine of 0 is 0. That's -1. Cosine of -1 plus 1 is 0. So it'd be -1 times 1, which is -1. So z sub x is -1, partial with respect to x. Partial with respect to y is easier. If I differentiate with respect to y, this is a constant. So you just have x cosine x plus y times the derivative of this expression with respect to y. That's just going to be 1. And again, I plug in -1, 1, 0. Put a -1 here, -1 here, and a 1 here. -1 plus 1 is 0. Cosine of 0 is 1 times -1. So z sub y is also -1. Okay, so z minus 0 equals fx -1 times x minus a -1 x plus 1 plus fy -1 times y minus 1. Okay, clean it up. It ends up being x plus y plus z equals 0 if you do the algebra. And that's what you get for that. Okay. All right. Okay, then let's see. Number 11. Now, there's a little bit more work here. They give you 2, 3 as the x, y. They don't give you the z. Can you figure out the z? Sure, just plug it in. Okay. That's sort of like, now, back here, they give you x, y, and z. Remember in Calc 1, find the equation with the tangent to the curve at the point 2, 5. Okay. They didn't actually have to give you the 5. They could have said, find the equation of the tangent at x equals 2. And so, well, I don't know the y value. Well, you can just plug in to find the y value, right? So here, it's best case scenario. They already give you the x, y, and the z. Here, they only give you the x and the y. So you have to jump through one more hoop to figure out the z, right? So f of x, y, okay, I plug in 2 and 3. So put a 2 here, and 3 here. 2 times 3 is 6. 6 minus 5 is 1. ln 1. And ln 1 is 0, so that's gone. So the z coordinate is 1. So it's 2, 3, 1. So they don't give me the z, but you can figure it out, the z. All right, so fx, partial with respect to x. Forget about that. Product rule. First times derivative of the second, x times 1 over xy minus 5. Then by the chain rule times the derivative of the inside with respect to x. That's y. That's a y there. Plus second function, ln xy minus 5, times the derivative of the first. Derivative of x is 1. Okay, so that's x times y over xy minus 5 plus ln xy minus 5. Okay, and partial with respect to y is a little bit easier because then x is a constant. So I just go x times 1 over xy minus 5 times the derivative with respect to y, which is just going to be x. Okay, so x times x is x squared. So x squared over xy minus 5. Okay, plug in 2 and 3. So 2 times 3 is 6. 6 minus 5 is 1. So ln 1 is 0. So this is going to be 0 for both of them. So I have 2 times 3, which is 6, divided by 2 times 3 is 6 minus 5 is 1. So it's basically 6. Okay, and then the partial with respect to y, Plug in 2 and 3. That's going to be 4 divided by 1, which is 4. Okay, so that's basically it. Okay, so now just plug everything in. Z minus Z0, Z minus 1, is fx, x minus x0, 2, plus fy, y minus y0, y minus 3. Clean up the algebra. Z equals 6x plus 4y minus 23. Okay. 15, f of xy is 4 arctan of xy at 1, 1. So again, they give me x and y, but not z. Figure out the z by plugging in 1 and 1. So plug in 1, 1. Arctan of 1 is pi over 4. So I have 4 times pi over 4, which is pi. So the order triple is 1, 1 pi. Okay, fx. Remember how to differentiate arctangent? So 4 times 1 over x squared y squared. It's 1 over this thing squared. Then by the chain root times the derivative of xy with respect to x, that would be y. And likewise, fy, 4 times 1 over 1 plus this thing squared, x squared, y squared, times the derivative of xy with respect to y, which would be x. Okay, so I plug in 1, 1, you're going to get the same thing. Plug in 1 there, 1 there. The numerator is 1, the denominator is going to be 2. So fx and fy are both 2. Throw it into the formula. Z minus Z0, Z minus pi is fx, x minus x0, plus fy, y minus y0. Clean it up. Z equals 2x plus 2y minus 4 plus pi. Okay. $17 is not really any different. It says verify the linear approximation at 0, 0. So see what it says e to the x cosine xy. The x plus 1, that's the back of the book. Pretend they don't give it to you and make the problem 17 just like 11, 13, 15, and you don't have to bother looking at the back of the book. The back of the book is x plus 1. That's all. All right, so you're at 0, 0. I need the y coordinate. Plug in 0 there, 0, 0. E to 0 is 1. Cosine of 0 is 1. So f of 0, 0 is 1. So the point is 0, 0, 1, the order triple. All right, fx, product rule. First times the derivative of the second, so e to the x times negative sine xy times the derivative of xy with respect to x, that's y, plus second function, cosine xy, times the derivative of the first, which is e to the x. Okay, now I plug in 0, 0. Okay, sine is 0, and that's going to make it 0 also. So I only have to look at this. 0, 0 here, cosine of 0 is 1, e to the 0 is 1, 1. F sub y is easier. If I differentiate with respect to y, e to the x is constant. So leave the constant alone. Derivative of cosine is negative sine xy. Then by the chain root times the derivative of xy with respect to y, that's going to be x. Plug in 0, 0. We'll put a 0 here. Sine of 0 is 0. So that wipes everything else out. So z minus z0, z minus 1 equals 1 fx times x minus 0 plus 0 times y minus 0. Clean it up. Z equals x plus 1, which is what they got over here also. Okay. Okay, and then some problems in finding the differential. It's not really that hard. You basically just plug it in. Okay, find the differential of the function. So it depends if you have 2 variables or 3 variables. Okay, if you have the 2 variable form, that one. 3 variable form, that one. Okay, so m equals p to the 5th q cubed. So dm is the partial with respect to p, dp, plus the partial with respect to q, dq. That's also dm is you differentiate with respect to p, 5p to the fourth q cubed dp plus differentiate with respect to q, 3p to the fifth q squared dq. That's it. That's all they want you to do. 29, you have three variables, alpha, beta, and gamma. R is alpha, beta squared, cosine gamma. Fortunately, they're all separated. So when you differentiate with respect to one, the others are constant. It's going to actually not be that bad. So dr is the partial with respect to alpha, d alpha, plus the partial with respect to beta, d beta, plus the partial with respect to gamma, d gamma. Okay, so differentiate with respect to alpha. That means all of this is constant. So I just copy the constant. Beta squared cosine gamma d alpha, plus then differentiate with respect to beta, 2 alpha beta cosine gamma d beta. Then differentiate with respect to gamma. This is constant. Derivative of cosine is negative sine. So negative alpha beta squared sine gamma d gamma. Okay, then finally 31, then I'm done. It's not quite 6:30 yet. So I'll be done in about 2 or 3 minutes. Then I'll open it up to questions and answers. And then whenever that starts, we can break and go straight to the test. Okay, so 31, z is 5x squared plus y squared, and xy changes from 1, 2 to 1.05, 2.1. Compare the values of delta z and dz. Now, delta z is just the actual change in the function value. You actually have to compute it. That's going to be more work. dz is a little bit easier. Okay, it's an approximation. Okay, so z is 5x squared plus y squared. So dz is the partial with respect to x times dx. So derivative with respect to x, 10x. Plus partial with respect to y, 2y, times dy. Okay, what are the dx and dy? This is like delta x and delta y. So I went from 1 to 1.05. That means dx is 0.05. I went from 2 to 2.1. That's a dy of 0.1. Throw everything in. So it's 10 times x is 1, dx is 0.05. Plus 2, the y coordinate was 2, dy is 0.1. Grind it out, 0.9. The calculations are very easy because it's all linear. Harder is to find the actual delta z. Well, that's the actual function value at 1.05, 2.1 minus the actual function value at 1, 2. So f of 1.05, 2.1, I plug it into here. It's 5x squared plus y squared. So 5 times 1.05 squared plus 2.1 squared. Obviously, it's more clumsy. Minus f of 1, 2. 5 times 1 squared plus 2 squared. Okay, so I grind that all out, 0.9225. Okay, so this is the true change in the function value, the actual delta z. dz, pretty close, 0.9. Okay, but this was a lot easier to compute. It's a lot faster. And there we go. Okay, folks, so that was all I was going to do for section 4, and I can mark it off. And that's it. So on Thursday, I'll go to 14.5. And a reminder again, next Tuesday is a flex day, no classes there. Okay, so I will let you ask questions now in preparation for the test, if you have any. So you can put it in the chat, but you don't have to. If you want to just start, we can do that also. Whoops, accidentally on the screen there, but maybe that's what you want anyway. Okay, try to get the chat back up there. Okay, so anybody with a question, please? And if not, we can just go straight to the test. Okay. 13.419. Okay, so I have requests for 13.419 and 13.319. And that's all I see at the moment. Okay, so let's go back and screen share. Okay. 13.419. Okay. R of t was t squared 5t and t squared minus 16t. That's to minimize the speed. Okay, we did do this one. So since I did it, I'm going to go fairly rapidly through it, unless you had a specific question about it. Okay, so R prime is 2t 5. Let me see, did I do that right? T squared minus 16t. 2t minus 16. Okay, so the speed is square root of 4t squared plus 25 plus 2t minus 16 squared. And you want to minimize this. Okay, I'll use the equivalent value. I'll use f of t is 4t squared plus 5 plus 2t minus 16 squared and minimize this. The same t value that minimizes this will minimize this. It's a parabola opening up, so I would just have to find the vertex and go from there. So that's as much as I'm willing to do for that one. Okay. 13.319. The paper's curling up on me. So let me try to uncurl it. Okay, well, you need to simplify. Simplify as much as is reasonable. Yeah. Okay, 13.413 also. Well, I don't want to switch back then. 13.413, since another question came in there. R of t is e to the t, cosine t plus sine t plus t. Okay, which really means distribute it. Okay, this is actually a fair question. I may only want to do one. R prime, so product rule. First times derivative of the second plus second times derivative of the first. It would be the same thing. And same thing here. First times derivative of the second plus second times derivative of the first would be the same thing. First times derivative of the second plus second times derivative of the first. Just review of the product rule. So that's R prime. Okay, and if you're going for the second derivative, let's see, there should not be a comma here. There should be a plus. Okay, so maybe I'll just suggest factor out the e to the t, cosine t minus sine t. Factor out the e to the t, cosine t plus sine t, and e to the t times t plus 1. Okay, so that's as much as I'm willing to do for that. It's just reviewing the product rule. Okay, I don't want to take up too much class time for that, so you can have more time for the test. Now, what was the other one? 13.319. Yeah, that one we talked about. I won't have you do anything like that in its entirety. Okay, it's a good problem for homework. Okay, but it did come out to be quite messy, as I recall. Okay, so we won't worry about that one for now. Okay. Now, it doesn't mean I'm not going to ask you for some of this. I might ask you for part of it, but maybe not the whole thing. Okay. All right. Anybody else, please? Wait just a moment longer. Okay, that's all I got. Okay, so let's see. I have 6:36 here. So let's try to start at 6:50. Right, so we'll break until 6:50. I'll send the exam to Canvas announcements, and then you can get started. Okay, so I'll put this now. I'm going to stop the recording. No longer need